Okay. Uh, you're going to kind of get a crash course in what ASTM does and how we created this standard. ASTM exists in order to make standards for a variety of things, anything from bicycle helmets, concrete, building materials, screws that go into airplanes. Basically, you name it, most utilitarian parts and processes have some sort of ASTM committee that makes a standard. And standards are made so that when something's manufactured, everyone is on the same page and has an understanding of what they should be producing. And especially, take for instance, like a bicycle helmet. We'd all want to make sure that the bicycle helmet we buy has an approval in that it protects the user against injury. And so if one company makes a bicycle helmet that sort of protects and another makes it well protected, we would never know that unless everyone would share in the ideas of what it takes to make something work properly. And so that's what ASTM does. Now, way down on this whole tree of committees is one called DO1, and they're an important committee because they do everything with paints. So DO1 has everything to do with house paints, commercial paints, and then way down on that is a little subcommittee called DO1.57, which is artist materials. And this subcommittee has existed probably since around the late 1970s, early 1980s, in order to make standards for art materials. There were none, basically. And most of these standards were focused around lightfastness. The one that everyone knows and is the most famous one is D4236, which is the safety standard, which means that products have to be labeled properly and tested for their safety. And so you'll see that on every product that you have, including your pastels. They do have to conform to D4236 in order to be sold in the United States. If they do not have that designation on them, and you cannot find that in their product literature, on the product itself, or the packaging, I would be suspect as to what is in those materials that are being sold. And we do know that there are some pastels that are making it into the United States market that may not be tested according to ASTM standards. But what we're going to focus on right now is the standard for artist pastels. And it is the latest standard that has been created, and it is called ASTM. And that stands for, oh, you see it on the top, American Society for Testing Materials. It's called D8330. So let me go down. How this all happened. Well, there are a number of people who were concerned that we were missing a standard, and that standard was the one for pastels. And so what we did, and this is now going on probably 20 or more years ago, we got some of the people on the committee. This was, I think, around the time that I started on the committee, that they assembled and donated pastels from about 9 companies. And that created a group of pastels for testing, which totaled 231. And what we had to do was what we do for all standards. We established a test method. Well, we had a head start on that because we know the tests that we do for watercolors, oil paints, acrylics, and we would apply that same standard, that same test for those materials. And so what we did was, and the test is rigorous. We're not fooling around when we make these tests. We expose paint samples in an outdoor setting, and people will ask, oh, why do you do it outdoors? Because exposure outdoors is the gold standard of being able to test the durability of the material. Nothing beats natural sunlight in a certain latitude within the world. And that happens to be, the best place happens to be in Arizona. And it's interesting, if you were to chart where all of the testing companies are, they follow the same latitude line along sort of the middle to southern part of Arizona. So all of the major testing companies have facilities out there for doing their outdoor sunlight testing. So what we did was to take that same application of taking a material and exposing it to an outdoor sunlight test. And so what we did was, first we did spectral measurements. So what we do is we use this device called a spectrophotometer, and we created a sample. So we rubbed this material out, stick form onto a substrate, and then burnished it and rubbed some more material on, and then rubbed it again and burnished it again and put some more material till we had a densely packed sample of pastel, probably about 1.5 inches wide by 1 inch tall on the substrate. We took spectral measurements. And what that does is allow us to understand you can reconstruct mathematically what the color of that material was by its lightness, by its how red or green that material is, or how yellow or blue that material is. And it all is in a 3D sort of matrix. Then what we did was we took samples that we did not expose, and we set them up and sent them out to a testing facility in Arizona and had them tested. They measured them, and we also collected data from them. And then we took those results and we shared it with the members who were in the subcommittee at the time. Then it turns into the long debate, how to refine the test method. And that's what really took the longest time. And I will show you the samples in a little bit, and I'll show you what really was involved in trying to figure out how to make a test that was worthwhile. Because there's no sense making a test that's skewed in one direction or another and isn't worthwhile to have as a test, because it's not really testing something. It's actually giving you a false reading. So getting test reliability and validation of the test is an extremely important thing. And between the math involved with this, as well as repeated testing, and I have to say, we tested these pastels probably about 8 different times, several outdoor tests as well as multiple indoor tests. So when we started our first round of tests, our observation indicated a problem. We didn't know really what was going on, and I will show you that in a little bit. Our pastels looked mottled. They basically showed white blotches all over them. So someone said, well, is this something migrating through the pastel? Is it some sort of a bloom problem? Did these things have dew fall on them? They are tested inside a box that has glass over the top of it, and these samples are well protected. The one thing that they weren't was they weren't protected from a lot of heat. So the kind of box that we originally used was a closed black box. And that box was suggested to us years ago because it was a vigorous test. It's basically the interior of an automobile. And you know how in Arizona, well, almost anywhere, how hot that environment could become. So we started to formulate a hypothesis. What was the issue that was causing the modeling? And we did indoor tests, we did outdoor tests, we looked at these materials carefully. And what we came up with was that this was some reaction that was going on in the pastel, either because some of the material was fading or the pastel mixture was not totally homogeneous. And what you were looking at was, barium sulfate or chalk or something or another that was in the pastel that was now fading at a different rate. But we knew that we could potentially solve this by not having the temperature up as high, because you do get odd things happening when you accelerate aging. It's not like natural aging where something has time in order to react to its environment and react to energy. All we're doing in any of these tests with light and light exposure is that we are subjecting a sample to energy. Light is energy, and we're subjecting it to that in order to determine whether it stands up to that or fails, which is what we call fading or the color being fugitive. So then we conducted a round robin test, and then we conducted more round robin tests and more, and collected more data. We shared those results, we debated them again, and then we submitted the standard for a vote once we established that we had solved all of our problems. Some of the early testing that was done, this was kind of the testing that was done before anyone had decided we were going to formalize this. And if any of you know Zora Pinney, these are her notes. Zora Pinney was an ASTM member and someone who was adamant about the quality of art materials and about doing her own testing. So she did these in her home. And as you can see, there's a covered side and an uncovered side along with this. And so she noticed that in some cases there was fading, in other cases there wasn't. She did a few more tests. She did start to notice, and as you will notice when you see samples 15, 16, 17, 18, and 19, and number 9 on the left side, that earth colors seem to do very well. But some of the other colors, as you can see on the opposite, well, even on the left side, number 14, this mauve, as well as number 5, this rose madder, didn't do so well. Carmine as well, number 3, and the reddish purple, number 4, also showed signs that it was fugitive. And then number 13 on the top, I've got something covered here, no. That also showed signs of fading. So we knew there were problems. The benefits of having a standard is that it doesn't become like this, whereas a home test, you're not really sure about the light exposure. Perhaps I think Zora used a blue wool card so that she could kind of determine a certain amount of light exposure, but it's a very subjective sort of mathematical sort of way of determining light fastness. So we need a uniform way so that everyone can use the same test. It's based on a reliable methodology that's created so that testing can proceed and everyone's basically on the same page, on the same playing field when doing the test, because there's no use making different tests and one test tests very well and another doesn't, but you'll claim that your materials test well when you use a skewed test. So part of what we also want to establish in any standard is to provide the labeling that we do for D4236, which should actually already be there for pastels as well as everything else. So any hazards that those materials might possess that need to be given to the end user so that they understand that, as well as labeling of the pigments so that they know what pigments are there. So establishing that level playing field of good labeling, a test that works, means that we have something that is verifiable and usable for manufacturers and that the public can rely upon. And it also then gives us a lever, which we'll talk about later, for artists to lobby for better products, because you can understand then that a test either passes or fails for a material. Now, there were criticisms of a few of the manufacturers that did attend our meetings, and I have to say, sadly, that very few manufacturers attended our ASTM meetings in the run-up to establishing this standard. And they said, testing is too expensive for manufacturers. So we addressed that issue. At first, we'd said, when you test, you're going to have to test every one of your colors and your mixtures. And in theory, that would probably be the best, absolute best thing to do, because we always had thought for many years that pigments are inert. They're just colored dirt. They're just colored chemicals, and they don't interact with anything. But we were proven time and again that that was wrong. Pigments do interact. They're chemicals just like anything else. They will interact and react with binding materials. They'll interact with each other. They'll interact with the substrate. They'll interact with the environment, and they'll interact with energy. which we know through either fading or some other breakdown of those materials that occurs when energy is applied to them. So then we revised our thoughts and said, okay, why don't you just test the raw single pigment materials that you have? And the people that were there did agree that that would be smarter, because in most cases, they may use 25 pigments, 30 pigments, but they're making them various combinations to make a line of maybe 140, 150, 200 pastels that they produce. So said, okay, test just those neat materials that are not mixed, that are not put in with anything else. And that seemed to be much more satisfactory. And we also did an analysis of what outdoor testing is like. And it really is extremely inexpensive. It is not expensive to do an outdoor test, especially if you don't have the testing facility do any sort of measuring, because measuring is expensive. It's costly to do measuring. So if they can do their own spectral measuring, then all you need to do is ship the materials to them, tell them to expose it to ASTM standards for light exposure. And what's nice is that paints, acrylics, watercolors, and pastels are all exposed to the same test protocol. So they don't have to look up something that says, oh, the pastel one has a different one. They just have, the only thing that's different is that they're going to use an open ventilated box, which just means that the box has no backing to it, but it has supports and screening on the inside that allows these samples to be put onto this matrix where they're held onto underneath glass. People were also saying, well, you know, the testing is overreaching because, you know, there shouldn't be, you know, ASTM shouldn't be doing this to any particular industry. And it's like, well, you know, we've established this test for all the other media that are out there. So there's really no reason to exclude pastels for that. Then people also said, well, Arizona sunlight is too harsh. Well, it hasn't been for paints or anything else. And it does not indicate, it does not overextend the test. It does not, it doesn't destroy samples. So we found that we could get relevant data, we could get useful data with the Arizona test. Then they said compliance is too difficult. Well, compliance to anything is difficult because it does require work. It requires somebody to actually make samples and do that. And most companies are doing that. So they are, they have compliance standards that they conform to. They conform to state standards for their materials and waste products. So compliance to a Lightfastness standard is not really that difficult. Now, the one that was the most tricky was compliance will eliminate beloved colors. That is possible, but the notion of, do you want people to have colors that they trust but are truly untrustworthy because they are terribly fugitive? The compromise is that you can keep your beloved colors, but you would indicate that they are fugitive. And we have history to back us up with this. I'll give an example. Winsor Newton made madder, alizarin, rose madder for years by a method that was archaic. And they labeled it as fugitive. They said, look, you can use this color. It's a beautiful color, but remember that it is fugitive. So buyer beware. You'll understand that that you might have to take precautions of how you display this. So you would use UV glass, you wouldn't expose it to great amounts of light. In many cases, you'd also use this color heavily so that it you wouldn't use it as a glaze. You wouldn't use it in light touches because it will fade over time. So you can kind of have your cake and eat it too. You could have this fugitive color, but you can also then warn people that this is going to be a problem. Labeling of hazardous pigments with scare pastel artists. That was the last point on this slide. And that's not really much of an argument because we label all our materials, especially those containing lead or other heavy metals in all of the other media that are out there. And it is a good practice to warn artists that there are issues with materials, especially with pastels, because as you know, the application of pastel creates dust. And that dust could be inhaled, it could be imbibed in some way. So understanding what's in these materials will allow you to say, okay, these are some of these materials I'll only use outside and I'll use with a mask, and I will make certain that I keep things safe. I will not be using this in my kitchen with my kids and my dog sitting underneath the table while the pastel dust blooms out, from that with no ventilation. So, I mean, these are common sense things to do, but they are born of being warned that something could be a hazard, and you take the necessary precautions. So let's get into the nitty-gritty of this. And what I did was, instead of showing you these cards, which there were probably about 10 or 12 of these samples on each card. So what I've done is kind of cherry pick the ones that give you an indication of problems. The earth colors behaved very, very well in most cases. It was really only certain other colors that showed what had happened when they were exposed to light. And I'll get back to something that I talked about before, the modeling, and you'll see it here. So what you're going to see in the first column on the left, hopefully on your screens, will be the unexposed sample. This is the virgin sample that never got to be put into outdoor light. Then you're going to see the middle column is the exposed indoor sample. So there are machines that these companies have that do Lightfastness testing, where you can put this inside a chamber. Some of these things are tabletop size, and others look like a giant refrigerator. And there's a deck inside with lighting that exposes a sample, along with a lot of fans, because these lights generate they're xenon bulbs, and they generate a tremendous amount of heat. In many cases, they have a water jacket around them and a cooling system to keep them from overheating the sample and catching on fire. So these are precautions that are taken. Now, the upside of indoor testing, you can do it any time of the year. Outdoor testing can only be done during the months of, I think, from October to March. So it's only kind of winter months that where the Arizona outdoor sunlight is. So if you miss that window of opportunity, you basically have to wait till next October to do your sampling or do your testing. So then what you'll see on that the right column is the exposed outdoor sample. And what I've put on the bottom of each of these, along with on the sides, was the name of the color, and then what Lightfastness rating that they received as a result of the testing that were done. The caveat here is, and this is something that we've talked about in ASTM for years, and something that's been preached for years, is that just because something measures well with a spectrophotometer, you must still use your vision and your brain to understand if something has changed or not changed. And that's a prime example, is the second one of ultramarine deep. But let's go through these and I'll show you. And I think I'm hoping that with these three samples, you can kind of see the unexposed sample looks rich, saturated. You can see that the color was applied in that little rectangle, staying within. We put these little guide marks in pen in order to kind of keep our samples neat and uniform. But as you can see, even in the cerulean blue sample, when they're handled by technicians, these are pastels, they're not fixed. So someone brushes a little bit, and all of a sudden you see color kind of being swiped away on that. But as you can see, the exposed indoor sample is a little bit lighter. And in my case, I'm looking at a monitor that I'm hoping is sort of calibrated. It kind of got a little greener. When we look at the outdoor exposed, you see that it's not uniform anymore. There's dark spots and light spots. And this was that modeling problem that we encountered. And we solved much of this by being able to go from a black box, the interior of a car, to a white box, or it's aluminum. So it's a light box that does not have sealed sides, that is well ventilated and doesn't allow heat to build up. Because even in winter in Arizona, the temperatures can rise to 90 to over 100 degrees in a sealed box, just like it would even in an automobile. Where you must trust your eyes as opposed to trusting the spectrophotometer. As you can see, the ultramarine deep has an ASTM Lightfastness level 1. But when you look at the sample, the unexposed versus the exposed outdoor, this sample is darker. This sample is not uniform to the way it is. Even the exposed indoor sample looks closer. But because of averaging and because of the way the machinery works, it can homogenize some of the data. And so you will still get Lightfastness 1 ratings on some of these things. But it's not a huge concern for us, because most of the time with visual examination, you'll do a retest in order to figure out if this truly is an aberration or it's something that should be considered. Now you can see the violet sample on the bottom. Its Lightfastness rating was, and these are Roman numerals, so that's Roman numeral 6. And you can see that is in the highly fugitive category. So it went from violet to a somewhat pleasing shade of gray. Not exactly what you were expecting if you laid this on in a painting, especially in a very large passage of it. To go from violet to gray would probably not be what you would consider artist intent. We have a few more. As you can see, even in the permanent alizarin crimson, it wasn't quite permanent, and it had faded to a much lighter shade. This orange in the middle also faded to a lighter. You see some of that modeling there. And cadmium yellow hue. And as you know, hue is not the original material. Cadmium, genuine cadmiums, do not usually have any sort of color shift. They are a workhorse of the pigment industry, and they're actually very good in high heat and any sort of conditions. And they were actually created in many cases for using in coloration of plastics, because they can take the high heat. But you can see a hue, which was something else, did not withstand the light exposure. There's another sample of alizarin crimson at the top. It also faded to some extent. The magenta, as you can see, went from a red hue to a sort of bluish purplish hue. So that failed in the high fugitive range. And then this product called red. And in most cases, we did not have the actual pigment materials to understand what these were. We just took the label that is on the pastel, and this just happened to be called red. It is a pinkish red. And you can see it faded to a lightish brown, not quite red as one would expect. The example on the top of lemon yellow is not so much a problem of fading as it is with pastels. As you know, when you get into the tints, you can get to the point where the amount of, in this case, it might have been a cadmium or a Hansa yellow, that was maybe 5 to 10% of the material in it. Most of the rest would be inerts or white in order to create those light tints. So you've got the problem of light exposure and very little pigment. So there's just not enough in there to buffer against exposure to light. You see the middle row of red carmine. This may have been a natural dye or an agent of like that, and it went from a pink, again, a tint that it started off. And as you can see, there just wasn't enough pigment in there to carry it through. That's interesting to note. You might see on that red carmine, there's a little red speck in the sort of middle, slightly to the right of it. If you take a fingernail, we didn't do this except on a few samples where I had some extras, but if you take your fingernail and rub off the faded part, you find some unfaded pigment below. So pigment does protect pigment beneath it. So it was interesting that the whole thing doesn't fade, and it indicated to us that heat is not the factor here. It is light exposure. It is light energy, not heat energy, that was causing the fading, because you could dig down to something that looked like that red carmine below it, or any of the other ones, especially the ones that faded. And you see the cobalt violet, very typical, goes from the original color to a much lighter shade. Most things fade and go light rather than go dark. Here's an example of vermilion, permanent red, and something called pink. Also had very high failure rates. As you can see, anything that goes really after Lightfastness 3, and Lightfastness 3 is even something I would be as fairly suspect, but anything in the past 3 to 4, 5, or 6 are definitely colors that are just going to completely disintegrate in terms of their integrity as the hue that you originally started with. Here are the last two. This is a blue-violet. And in some cases, you see that the pigment goes light, but also goes gray. So this was sort of some of the artifacts that we were seeing with these colors fading unevenly or fading to a lighter grayer shade. And in some cases, we were again thinking that some of this was the inert materials that were showing through much more rather than the pigment itself fading, although the pigment fading was a considerable factor in it. And the last one there, you see the orange red. And you see the numbers next to it. This is how we labeled all of the products, so that for one, we couldn't put the whole manufacturer's name and the color and everything else. So we just put numbers in for everything. And it also allowed us then to, at the meetings, to share these panels that we had. They were, 7 or 8 inches wide, and so 4 or 5 inches tall or so, so that we could share these with others and not reveal the names of the manufacturers. Because the idea wasn't in the round robin to shame anyone. The idea was purely to see how the test works and what some of the problems that we faced. Now, what happens in many cases is that a round robin will stimulate a company to suddenly reformulate 3/4 of their line. We saw it in the paint industry. We saw it in watercolor. We saw it in oil paints. We saw it in watercolors. We saw it in acrylics. A lot of companies, once we talked about in ASTM the written up results, they came back and said, no, don't worry about us. We already reformulated all those colors that came out badly in the test. Now, we never went back and retested those colors again, and that wasn't necessary. But it was a good reminder, as well as a good stimulus for responsible manufacturers to do something about the colors that they found out that were fugitive. So there were good things that came out of that. What we found in a summary of our test, and now we'll get into a little bit of the aggregation of the math that came in with this. We found that indoor Lightfastness machine testing is comparable to outdoor. Now, as I said before, we know that indoor testing is expensive. So a whole lot, by the factor of every 3 or 4. So if an outdoor test may cost, $2.75 for the test, you can, an indoor test with the measurements and all the stuff that they do, because they rotate the samples, they do a lot of things with samples in these indoor tests to create more uniformity. They can run $7 or $8, $9 a test. So they are more expensive. But what we found out was, and I thought it was subtle, but it was a poignant message to our committee, was that the indoor test, if something was going to fade, it would show it a small amount. But if you did the outdoor test, it would show it by a much larger increment. So if a company, and several manufacturers, not necessarily pastels, do have their own indoor test chamber that they've purchased. Sometimes they get them used, they get, or they bought them years ago so that they weren't as expensive. So they do some of their own indoor testing. So they don't have to go through the expense of the bother of going to outdoor testing. If they can test indoors and they see that there is some sign of change and fading in their samples, there's a great indication that's going to be correlation with outdoor testing. So while we prefer outdoor testing, the indoor test does give a good indication that something is fading. Now, here's the one that's probably going to be a little bit hard to swallow. Failure to achieve a Lightfastness 1 or 2 rating was 52%. So over half of those, 381, I think I said, pastels that were in that, over half of them failed to reach Lightfastness 1 or 2. That was pretty bad. So as I said, earth colors did well. Those are the ones in the winning side of this. Pastels requiring a third tie-breaking test. As I had said, if you do a test, in many cases, you're doing maybe an indoor test and an outdoor test. That would be in the ideal world, you'd kind of do both. But in many cases, pastels might be, or any other art material might be exposed with just 2 samples. And even if you're doing 2 samples in different parts of the testing chamber or different parts of that, you sometimes get one result that shows you a huge amount of failure and the other one that it's wonderful. It's a Lightfastness 1. And then you get a Lightfastness 3 or 4. So in many cases, what a company would be then encouraged to do is do another test. So that one breaks the tie. If it fails, you've got 2 failures against 1 success. You take it to you rate it at the failure point. So if it's Lightfastness 3, you rate it as 3, you rate it as 4. Or you drop that and reformulate, use something else. And as I said, so that to determine that was about 38% of the samples would need a tie-breaking test. And as I said before, earth pigments performed very, very well. Now, why were pigments performing poorly? We suspect, we did not do analysis, but we suspect that those pigments that did poorly were dye-based. We know that fabric dyes will fade over time. We know that dyes in general do fade over time. They are not as robust as pigments. Dyes have much smaller particle sizes. They are really colorants that do well in aqueous solutions. And so that's why dyes, work so well to be able to dye cloth. They dye chalks as well. So that is one reason that dyes were adopted by the pastel industry. The other is that if any of you are painters in different media, you will notice that pastels have definitely a range of extremely high chroma colors, colors that go far beyond what you'll see in watercolor, oil, or acrylic. And because being able to use dyes extends that range, it allows you to have, these bright pinks, these fuchsias, these dazzling colors, but unfortunately at the expense of the potential for them to fade. And that's what we saw. In many cases, these dazzling colors just completely fell apart when exposed to light. And some of them, something I didn't mention before, but it gets into the minutia, but we did part of one of the round robin tests where we tested these things intermediately. Many tests, especially those commercially done, you give them their sample, you have them expose it for the amount of time. They don't do intermediate measurements. Basically, the timer goes off. There's a counter that says how many megajoules of energy these things have been exposed to. And when that little receiver in the chamber goes off and it says it's reached 440 megajoules per meter squared, test is over, done. So you measure it then. But we did one of these tests, we did intermediate measurements. We did measurements early on. And after only 2 or 3 weeks, some of these colors were already fading. So these things we suspect that some of these were fugitive within days of being applied and light exposure happening to them, because these dyes just cannot withstand light exposure. So the outcome of all of this and the take-home point, the action point of this is the sentence that I have below. Consumers need to demand that manufacturers use safe, permanent, light-fast pigments to make pastels. It's really as simple as that. ASTM is not a consumer advocate body. We just make tests. That's what we're good at. We are not a legislative arm. We don't strong arm our manufacturers. We don't shame them. As a matter of fact, if we chastised and shamed them, they'd pretty much stop coming. Because to be honest, ASTM, other than D4236, the health and safety standards, all the other standards are voluntary, including the pastel standard. So you cannot put a gun to their head and say, you've got to do this. It's voluntary. There's no United States legislative laws, nothing in CPSC that tells them that they must conform to a standard. So the only tactic you can use that has any strength is for consumers to make that demand to pastel manufacturers to change the products that are fugitive. And in some ways, how to do this is that we've always encouraged consumers to do their own testing, do their own in the window testing to see, especially some of the suspect colors. Forget the earth pigments, but especially some of the suspect colors to see if they fade. And then you can report with some confidence back to the manufacturer that they've got problems with their products. And if enough people make these demands of manufacturers, I think they'll listen. I'm hoping they'll listen, and I'm hoping that they will maybe even come to ASTM and ask for help in how they can do this, because we're here to at least help them conform to a standard. We unfortunately can't force them to conform to a standard. And I know a lot of people have complained, it's like, why can't you do something? And it's like, well, that isn't our role, and there is no enforcement policy, and there are no penalties. So there's really, we're a paper tiger. We can't make any manufacturer do something. We can't shame them into doing something. So the only thing that we are capable of doing is to encourage and to educate and to work with them in partnership to try to make this happen. And so that's really my plea to you. We have we've had over the years various speakers who have come to IAPS and have sent out this warning based on some of those tests that I just showed you that pastels have a problem. The first few people that heard this were perplexed, aghast, confused, angry. You know, it sort of went through all phases, but we didn't have a standard. So we didn't have D8330 to fall back on and saying, here's what you need to do in order to conform. So we were just basically voicing a problem. And then what we were able to do after that was in earnest really start this testing and development. And really what we got hung up on, why it took so long, was that the perplexing problem of the modeling effect. We needed to figure out how to solve that. And so successive tests, pondering, you know, basically scratching our heads and getting together over several meetings and wondering out loud. And finally, then talking to some people in what the testing people, we call them the weathering people. They do weathering testing. Some of the weathering people chimed in and helped us solve that problem by saying you need to switch from the black box, which was the standard for all of the things we were doing, and which we are changing for all of the other tests, to the open ventilated box. And that solved our problem. And that gave us the confidence then to say, we have a test that is valid, that is useful, and that a consumer can then say, please fill in the blank for a manufacturer, conform to the standard D8330 for your pastels. It will give us confidence to purchase those and to be sure that our paintings will stand the test of time as best as possible. Because as you know, pastels are vulnerable from scratching, vulnerable from air movement, vulnerable from light. Pastels, or the pastel paintings, are probably the most problematic for any museum to lend to another museum, just from the point of view of transport. As you know, and you probably do this yourself, pastels are matted in many cases with a reverse bevel, so that if anything falls off, it falls behind and not in front of the mat. It's very disconcerting to lend a pastel to a museum and to find out that the vibration during transport has caused it to, you look in that little trench below the bevel and see chunks of pastel down there. So you know that the work of art has lost something in that, and you can't exactly go and glue it back on. So we know that pastels have that vulnerability, and especially not being bound to a medium, you have the perfect storm of pigments that have no binder over the top of them, except the protection of like UV glass, to safeguard them from being exposed to light that could fade them. And so by being able to have robust colors, you can then mitigate that problem. So in other words, get rid of the dyes, or keep the dyes, but warn people that these are fugitive, that they will fade, that they will have problems, and let the buyer beware. That's really kind of the key to that. In conclusion, our manufacturers that did attend, they did not respond in a very positive manner to our round robin results. There was a manufacturer who said, this can't be done. And it's like, well, yeah, well, the problem is when you did your indoor test, the fan speed of the indoor chamber was so high, it actually moved the samples around. and scrambled them, and they were useless. So they basically said, there's no way you can do it. Well, I said, well, you don't have a fan in an outdoor test. They are sitting there rather quietly under glass. So that, is a way of getting around that. ASTM meetings didn't attract a lot of major manufacturers, even though they were told that we were creating a pastel standard. That usually draws them out, just out of curiosity sometimes, let alone changing anything. Adopting the pastel standard was met with some passive resistance. And I have to say there were a manufacturer said, don't release this because the economic times are gloomy right now, and having a pastel standard would just be an undue financial burden. And we don't respond to something like that because a standard is a standard. You can abide by it or you can ignore it. It's not going to have an impact on a particular company, and it's not targeted as a tool to have impact on a company. And other than IAPS, no consumers or artists have expressed an interest in the pastel standard, unfortunately. So this presentation, as well as other talks, I just had an article published in Pastel Journal on the standard and explains it. It doesn't talk about as much about what I'm telling you in terms of the details or the call to arms to become a lobbyist to the pastel industry and have changes made. And then that final point, manufacturers should be pressured by artists to adopt the pastel standards to achieve at least 95 to 100% of lightfastness in all the colors that they produce. If you want to contact me about any concerns or questions, or you have some details, there's my contact information in a Gmail account that I have set up. As subcommittee chairman for DO 1.57, we also encourage consumers to become part of our organization. $75 a year. And all of the discussion you can ever take about art materials at any one given time. I also run a website for myself called The Syntax of Color. And I talk about pastel issues. I talk about all kinds of artist material issues there, about the history of pigments, about how products came about art materials advertising, which is a sort of an interest of mine, and about the industry in general. So as I understand, there are no questions here. I'm sure you have some, but I think that's going to be held for a later date. And I think I've used up my time, hopefully, as best as possible. And I hope that I've inspired you to inspire your members, since you are presidents of pastel societies, to get out there, look at their materials, to contact manufacturers, and to plead with them to conform to the pastel standard, so that artists can be assured that they have materials that are lightfast and as permanent as possible. Okay, thank you very much.